Hi guys, today we will learn about insertion sort algorithm. Now, before I explain you the same, let me first give you a real life example. I'm sure all of you must have played cards at some point of time or another. You would remember that you sort cards in your hands in the beginning. How do you do it? Let us take an example. Suppose I have these 4 cards. You can see that they're unsorted. How will I sort them? I first bring 2 before 5 and then bring 7 between 5 and 9. At this point, my cards have become sorted. This is basically the same way insertion sort algorithm works. Now, before I explain you the algorithm in more detail, let me first explain you the insertion step. To explain you the same, I will take a list of 3 elements, 2, 5 and 10. You can see that the list is sorted. Let us try and insert 3 in it. How do I do it? I first compare 10 and 3. Since they are out of order, I swap them such that my list becomes 2, 5, 3 and 10. Next, I compare 5 and 3. Since they are again out of order, I swap them again such that my list now becomes 2, 3, 5 and 10. Now, I compare 2 and 3. I see that they are in order. So basically, I have used 3 comparison and 2 swaps to insert 3 into the sorted list. Now, let's come to the algorithm, how it works. Initially, we take a list of elements and divide it into 2 parts, such that the first part, indicated by red, is the sorted part, and the second part, indicated by blue, is the unsorted part. Now, at each step of the algorithm, we take one element from the unsorted part and insert it in the sorted part, such that eventually my entire list is sorted. Let's work our way through an example to see how it works. Let me take a list of 5 elements, 24, 13, 9, 64 and 7. Since my list is unsorted, I am showing it in blue. Now, in the first step of the algorithm, I will insert 24 in the sorted part. You can see the sorted part contains nothing. So I simply bring 24 to the sorted part, such that my list now becomes 24, 13, 9, 64 and 7, with the sorted part being 24 or one element. Now, in the second step, we will insert 13 in the sorted part. Since they are out of order, I will swap them, such that my list now becomes 13, 24 and the unsorted part contains 9, 64 and 7. At this point, I have 2 elements in the sorted part. In the third step, I will insert 9 into the sorted part. You will see after 2 comparisons and 2 swaps, my sorted part will become 9, 13, 24 and my unsorted part contains 64 and 7. In the fourth step, I will insert 64 in the sorted part. Since 24 and 64 are already in order, 64 is already in its final place. So my sorted part now becomes 9, 13, 24 and 64. And unsorted part contains only 7. In the final step, I will try and insert 7 in the sorted part. After 4 comparisons and 4 swaps, my sorted part will become 7, 9, 13, 24 and 64. You will see now I have used insertion sort algorithm to sort the initial list of elements. I would like to point out one more fact. Even though I am showing the sorted and unsorted part in different colors, they are essentially the same list. Now, you must have also realized one benefit of insertion sort, that it takes advantage of the pre-sorted array. Essentially, this is a very important aspect used in practical applications because we can use this to insert an element into a list of already sorted elements. That's it for the video guys. I hope it helped. Thank you.